Okay, so some of you have found an answer for the first one, but I'm more interested in how you found the answer because I think that there are a couple different ways to do this. And if I tell you one way, that might help a couple students, but it won't help all the students. So I want to hear the different ways that you solved the first problem.
If 12 eggs cost $3, how much do 3 eggs cost? So I divided 12 by 3 to get how much 4 eggs would cost.
Let's see, so 12 eggs divided by $3.
Yeah. And then I got 4 for that, and that was 4 eggs, which cost $1 each.
So 4 eggs cost $1.
Yeah, and I divided it by 4, and each egg cost 25 cents.
And then you did $1 divided by 4, so you got 25 cents per egg.
And multiply that by 3 to get how much 3 eggs would cost, which was 75 cents.
Okay. So I just want to repeat what Shelby said for her process, and then I'll take a different idea from somebody else. So she divided the eggs by $3, and that gave her 4 eggs for $1. These are equivalent fractions. And then she said, okay, $1 for 4 eggs, I can split that $1 into fourths, and I get 25 cents per egg. And then I can multiply that by 3. Did anybody else use Shelby's method? Okay. Who can tell us a different way that they solved it? I know that there's some other answers out there. Yep, Nadim, go ahead. So you did 3 divided by 12. So $3 divided by 12 eggs. What did that give you? Okay, so this is going to be 25 cents per egg. And then what? Okay, so 25 cents, 25 cents times 3, and you got the same answer? Cool. 75 cents for 3 eggs. All right, so I want to repeat Nadim's method, and then I'm going to ask who did that method, okay? So he did $3 divided by 12 eggs, which gives you 25 cents for 1 egg. And then multiply the 25 cents times 3 to get 75 cents for 3 eggs. So raise your hand if you use Nadim's method. Okay, Dion and Stephanie did, and Amro did. Anybody else? And Lonnie did, good. All right, who had another method? Okay, there are a few other ways to think about this for sure, but these are good methods. So if you liked one of those methods, let's get that method down and see if it helps you do the next problem, okay? Notice that both students found the cost for 1 egg before they translated that to the next step. Not necessary, but it seemed to work out for both students. And you don't have to write both methods down, just write down the one that makes most sense to you. All right, so we're gonna move forward. Did anybody use Nadim or Shelby's method for number 2? Raise your hand if you use Shelby's method. Raise your hand if you use Nadim's method. All right. I think you did use one of those methods. I think you just lost track of which was which. So 4 cups of oil cost $3. Did anybody take the $3 and divide it by 4? Yeah? It doesn't divide nicely, does it? What do we get? $3 divided by 4 cups.
I think we get like 75.
Yeah, 75 cents. Good. All right, so we get 75 cents for 1 cup. All right, so a half a cup of oil, should that be more or less than the price for 1 cup of oil? It should be less. So we need to make sure that the answer you got is less. Can anybody explain the next step? Go ahead, Dan. What did you divide by? So that's interesting because I think you might have done that in your head, and you think of it as dividing by 1/2, but when you actually divide by 1/2, you get a bigger number. And I think some people were getting stuck on that. Yeah, that's what I was thinking you did. All right, so a lot of people got stuck. They did 75, cents divided by 1/2. 1/2. And they got a bigger number, right? And they were confused by that. And then what Dion did actually was he divided by 2 to get a smaller number. Did anybody multiply by 1/2? You did? Yeah, because multiplying is actually the step that we did in the last one. And they actually both work. You can divide by 2 or you can multiply by 1/2. So 75 cents for 1 cup times 1/2 or divided by 2. And we get 37.5 cents. You can round it, but if you round it to 38 cents because the 5 is going to round up. Okay? So you can leave it like that or you can round it to 38 cents for 1/2 cup. Now, when you guys are doing your projects, you're going to need to do things like that. If you look at the baking list from Giant, at the end, it's telling you some of the ingredients that you need, how much they cost, and you don't need to buy 8 eggs if you don't need 8 eggs. Now, in the real world, yes, you do, but we're going to account for that at the end of the project. Okay, so we're going to do the project in this idealized way, and then we'll account for anything that disagrees with the real world near the end of the project. All right, so this one's talking about profit. Profit has to do with money. I know you guys know that, right? But when you have a bake sale, all the money that you get is not profit because what did you have to spend money on? Supplies, right? Okay, so sometimes like your parents might donate supplies, but you know, in the real world, your profit is the money that's left over after you pay back for the supplies. So in this case, a lot of you figured out that if you have 24 cookies and you sell them for 50 cents each, what do we do with those numbers to find out how much money you get at the bake sale? 24 and 50. Should I add them, subtract them, multiply, divide? So you got 24 plus 50 is 24.50? No, I think you did something different. What'd you do? So 50 cents for each cookie, right? But there's 24 of them, so I get more than 50 cents. You get $12. Yeah. How do we get $12 out of that, guys? It is, right. So 24 cookies times 50 cents for each cookie is $12. But we don't get to keep all $12, right? Because we have to pay back for the supplies or the ingredients. So $12 minus the $5.50, and our profit is $6.50. So that's the difference between the money that you take in and the money that is your profit. Does anybody know who Sophie is? My daughter. Might show up in a Kahoot sometime. My son's name is Ben. Anyway, she really did actually make cake pops for a bake sale, but she made cake pops and cookies, not cake pops and brownies. And the cake pops did take forever to make. Has anybody ever made cake pops? No, they take forever. So each batch of cake pops took 4 hours to make, and the ingredients cost $8. And each batch of brownies took 1 hour to make, and the ingredients cost $3, right? So it seems like these cake pops take a lot of time and money to make, but it pays off because let's look at the profits. Well, before the profits, we know she has $48 to spend in 12 hours of time. So she's going to earn $30 profit. That's not just the money she takes in, that's the money that's the profit, okay? For each batch of cake pops, and she gets $10 profit for each batch of brownies. So what we have to figure out here is it worth it in terms of time and money that she's spending on supplies to actually make these cake pops instead of the brownies? So define your variables. We're going to have X and Y, right? Who can raise their hand and tell us what X and Y should represent? I see one hand. I'm looking for a couple more today. Any other hands? Stephanie, how about you? Can you tell us what does X and Y represent?
X represents cake pops and Y represents brownies.
Cool. Now, you can actually get the completely right answer if you said those backwards, but if you set them up the same way, then it's easier to follow along the work, right? Because everything will look different until the end answer if you set them up backwards. So in general, the guideline I've been giving you so that you can follow along with the class work is just make X the first thing that shows up and make Y the second thing that shows up. Mathematically, it doesn't matter. It's just so that we can check our work against each other's. Lonnie, you with us? Thank you. Okay. Write your objective function. Now remember, your objective is your goal, and if you look at the last sentence, find the last sentence in the problem. Our goal is to maximize what? Profit. Good. So our objective function should be about the profit. Okay. So see if you can find the profit numbers for cake pops and for brownies. If you haven't written that objective function yet, let's write it right now. Kelly, can you give us the profit equation you found? 30x plus, say it again, 10y. Good. Now, I know a lot of you are looking at different numbers that were about money, but these are the ones that we want because they had the word profit with them. Now, some of you guys use those other numbers, and those are going to show up in a constraint. Who has a question about our objective function? So it's our goal to maximize the profit. Nadine, can you get that? Got that? Perfect. All right, constraints. So Sophie is limited in making her cake pops and brownies. She cannot make an infinite number. How is she limited? What's one thing that limits her? Time. Good. Let's write one about time. Okay, so how much time does she have? She has 12 hours. Can she use more than 12 hours? No. Can she use less? Sure. So she can use less than or equal to 12 hours. Does anybody want to share with us the rest of this inequality? Raise your hand if you think you might have it. Dion, let's give it a chance. 4x 1y. All right, raise your hand if you have the same inequality as Dion. 1, 2, 3, 4, 5, 6. A lot of agreement. I like that. All right, so let's just check back and make sure the numbers make sense. Cake pops took 4 hours, yes. And brownies took 1 hour. Very good. And all that time is going to be less than or equal to 12. What's the other thing that's limiting Sophie from making infinite cake pops? Her budget, right. So she only has, let's see, $48 to spend. So I like that word. I'm going to use that word budget. And so this time we're looking for the money she's spending, not the profit money. And it's tricky when there's two different things that are money. So we've got this one here, and we've got this one here. Does anybody think that they can share the inequality for the budget? I see one hand. All right, Shelby, give it a try.
8x plus 3y is less than or equal to 1.
Okay, if you agree with Shelby's inequality, raise your hand. 1, 2, 3, 4, 5. Okay. Who has a question about these inequalities? Okay. All right, now some of you may have also put down x is greater than or equal to what number? 0. Good. Because we can't have negative cake pops and we can't have negative brownies. Sometimes you can figure out these points even if you didn't write them, but it's good practice to write them. All right, so the next step is to go into Desmos and we're going to graph 1, 2, 3, 4. We don't graph the objective function, but graph these 4. I'm going to graph them as well, but I want you guys to graph them first so that I don't ruin your fun. All right. So here's one at 0, 12. Here's one at 3, 0. Now technically there is also one at 0, 0, but we know she's not going to make maximum profit if she makes no baked goods. So you don't really even need to write that 0, 0 down, but if you want to be thorough, you can. So I'm going to put 0, 0, 0, 12, and 3, 0. I'm writing this on my paper for part D.
How about 6, 0?
Oh, excellent question. All right, so some of you have noticed that there's some more points, like 6, 0, and this one up here, 0, 16, right? Now those points aren't corners of the feasible region because the feasible region is the area that's shaded by all of them. See this part, so this part here? This here, it's just missing this one. Okay, so it's the innermost region there. Beautiful question. Okay, so let's go back to our worksheet. I put those corners that we just found on there, and now it says, substitute the vertices into the objective function to find the number of, oh, it says meals, profit, to find the profit for each point. This is what happens when I keep trying to change the one from the day before. So we're trying to find the profit for each point, and our profit, our objective function is right here in part B. So I'm going to write 30x plus 10y, and then I'm going to substitute my point in, and I told you that 0 was not going to be the answer, and you can see that that's absolutely right, because I get a profit of 0 plus 0, which is 0. All right, so let's do the other two and figure out which one gives us the best profit. So this one gives us 120. And that one gives us 90. So how much is the maximum profit? What's the most you can make? $120. Good. Now looking back, 0 is the X and 12 is the Y. So she should make 12 batches of what? Brownies. And no cake pops, which is sad because cake pops are fun to make, but they took too long and they cost too much to make. And so, so it turned out brownies were the best way to go. So we want to write a sentence. She should make 0 cake pops and 12 batches of brownies. So that means like 12 trays of brownies. That's a lot. And she'll earn a profit of $120.